Welcome. I'm going to do another problem from 4.7. This is a little more exciting than the Farmer Bob problems. Excuse me. But we have a box, and I love these problems. It's a box with a square base and an open top, and they want it to be constructed with a volume of 13,500 cubic centimeters. And what we need to do is we need to minimize the amount of material that we use. So again, we need to find, we're going to always be taking derivatives, but to begin with, let's draw a picture. Let's use blue, that's a nice color. I'm going to try to draw a box. Haven't done this in a while, so don't laugh at me. Okay, so here's our box, and back here you can do fun stuff. If you like art, you can do stuff like that. Oh, if you like art, you can do stuff like this. My mom just texted me. Okay, so here's our box. Now remember, this box has no top, and it has a square base, and I'm going to label the base X and X, and I'm going to label the height of the box Y. Why? Because I like that variable. And the volume of this box, equals X squared times Y. Base times length times height. And we're given that the volume of this box has to be 13,500 cubic centimeters. So what's our constraint equation? That's right. Our constraint equation is 13,500 equals X squared times Y. All right? And what we want to do is we want to minimize the amount of material, which means we need to compute the surface area of this cube. And how many sides does a cube have? That's right, a cube has 6 sides. However, our cube only has 5 because we are not building, our box does not have a top. Now the bottom of the box, its surface area, I'm going to use S for surface area, is X squared. However, each side of the box has a surface area of X times Y, and there are 4 of those. So the surface area of this box is 4X times Y. This is the quantity that we want to minimize. This is the quantity that we're going to minimize. And as usual, the great thing about the constraint equation is it allows you to solve for one of the 2 variables. In this particular example, the way I have it labeled, it's easiest to solve for Y. Let's use purple. It's a friendly color. So I get Y equals 13,500 divided by X squared. And now I can take this Y value, plug it over here into the surface area of the box, and I can now have a formula in one variable. Let's go back to blue. I get that S equals X squared plus 4X times 13,500 divided by X squared, which equals X squared plus, I think that's 52,000. 4 times 13,500. That's 52,000 divided by X. And so now, as usual, what do we like to do in calculus? That's right, we like to take derivatives. And let me just rewrite this one more time in case you're wondering. I do not want to use the quotient rule. Maybe you do, I don't. So I rewrite it this way, and now I'm going to compute the derivative. Compared to the derivatives we were taking 5 weeks ago, I would say this is a meatball. So this is 2x minus 52,000, x to the minus 2. And let's go ahead and rewrite this in a little bit friendlier form. That's 2x minus 52,000 divided by x squared. And now what we need to do is locate the critical numbers. Notice in this particular problem, there is no smallest value. All we know is that x has to be greater than 0. And let me point out why x can't be 0. If x is 0, look up at our constraint equation. If x is 0, there's no way you can pick a y value that when you multiply it by 0 squared, that would give you 13,500. So we don't have a closed interval. X has to be strictly greater than 0. And again, there's a little extra work you should do to check that the value we get really is the minimum value, but it's going to work out. And I can make a video on that later if you like. Okay, so here we go. I need to solve s prime of x equals 0. So that gives me 2x minus 52,000 divided by x squared equals 0. I'm going to bring this piece all over here. So that gives me now 2x equals 52,000 divided by x squared. And I'm going to multiply both sides by x squared and divide both sides by 2. So this gives me x cubed equals 26,000. And I need to solve. Let me just take a little peeky poo. Ooh, I made an error. This is not 52,000. This is 54,000. There are 3 types of mathematicians. Okay, all these things I'm scribbling out should be 54,000, and that's going to be wonderful. Because remember, all these math problems in these textbooks are designed to work. And 54,000 divided by 2, as luck would have it, is 27,000. And you're not going to believe this, but 27,000, I believe, is a perfect cube. And I believe 90, if you take the cube root, you get x equals 90. Isn't that wonderful? Now, we haven't found the dimensions yet. I know x equals 90. How do I find the corresponding y value? That's right. I go back up to the constraint equation, and I have to plug in x equals 90. So y equals 13,500 divided by x squared. That equals 13,500 divided by, what's 9 times 9? 81 and 2 zeros. So whatever number this is, this number is fine with me. So the dimensions of the cube that minimize the amount of material that you need to make a box with volume 13,500 is x equals 90. That's the base of the square of the cube, which is a square, and y equals 13,500 divided by 8,100. I hope that helps. Talk to you soon.